Hey Stringer here. So today I'm going to working on this is like a chalky shit. This is basically a jar. I have made some hypochlorite and some hypochlorine solution. This is the chlorine solution, the hypo solution, and there is no focus. And the lights are shit as well. But the main thing is that I am trying out like a new methodology, or at least some sort of methodology, to make more calcium chloride, I believe. Yeah. So it is the CaCl2 version of the. There is absolutely no fucking focus whatsoever. So yeah, this flaky shit. I mean, it is solid, but when you mix it up with like alumina, it will not like cake up into a fucking solid rock bottom layer like that, but that has like water, so that's why. But as it sucks up the water from the air, basically it is hydroscopic, and as it sucks up the water from the inlet air, it cakes up first. Then when it is caked up, then after a while it will like liquefy, because the calcium chloride can suck up like 6 times its mass water, so it is quite good in the sense of like acting as a desiccant. The only problem is that it reacts with the sulfuric oxides, which is not the best, and that's why we cannot use it after the burner at any stage. So that's why I will change the there is probably zero light. Zoom in. As you can see there, the little beads there are alumina beads. They act as acid desiccant as well because they are activated. The only issue is that they are not as good as this. Catch the water from the moisture of the air better. But as I said, the problem is their reactivity. So that will be changed because that's the initial like pre-filter before the burner. That will be changed back to calcium chloride, and that one and that one and the black one, those will be removed, and they will be filled up with alumina beads. So they don't need that much desiccant power, let's say that way, after, because they go into the desiccant and then they go to the condensation column, whatever. So there's always a condensation column there, and there before every single catalyst. But this is basically the last one before before it goes out to the scrubber. That one behind this, the pipe is not connected. So there is always a condensation column to catch the remaining sulfur dioxide. This dioxide doesn't like see that I'm like vacuum drying this shit. And what I will do with this calcium, this chalky shit, this is the calcium hydroxide that's left from the, that's been left from the unreacted calcium. This, on the other hand, this clean water, this is hypo solution, and that will be heated in a jar like this, and then it will break down the, first of all, evaporate the remaining water, as well as like break down the hypo into calcium chloride solution, and then we will have some amount. I have no fucking clue how much, but we'll have some. Just trying this method out so we can see that it either it works or not, whatever. Because the other like how do you say it? Route is like not that good when you mix the HCl, so hydrochloric acid, with the calcium hydroxide. That's not the best route either, because that is more manual and it takes a lot of time to break up. If this way we can make it, basically this is like half automated, because this, as you can see, it spilled all over as it was bubbling. Basically what I did is that I have watered up this chalky like calcium hydroxide, this slag line, and use the pump, the adjustable PSU and the pump to basically pump air into the chlorine or chlorate cell. And the chlorate cell's output pipe, which basically bubbles hydrogen and like chlorine gas into the flask. This basically acts like a scrubber. This catches the chlorine as much as it can, and then it basically reacts with it and it creates some amount of calcium chloride, but mainly calcium hypochlorite rain, and in the cell it creates chlorate as well. So I'm out here at the place. I probably fucked up in the sense that I should have not let the this is the chlorate cell. This is just a regular jar with the, as you can see, there is like a mesh of titanium. At the bottom you can better see it. There's like a mesh of titanium, and there is some red stuff here that probably the chlorine solution, the chlorate, the water just evaporated or not evaporated, but like dissolved the what's that, the platinum that was being gazed onto the electrode, but I don't really give two fucks about that. As you can see, this was solid and now it liquefied, which is a good sign in that sense that it will, as it like cools, it will cool off and it will basically like solidify on this as well. The first you need to like dry it. Stinky fucking shit. I almost like said that, yeah, let's add the bar, the stir bar, but the main problem with the stir bar is that when this will solidify, I mean, I can add it, it doesn't matter, we will boil it down anyway, or at least like reduce it in volume. So now that we are here, I'm just going to talk because I have time. So the two things that I'm facing right now is that, first of all, the burner is not working properly, and that's why I'm fiddling around with these desiccants, because I have changed the initial jar, where is it? So it's in the behind. That one, basically to the alumina balls or beads, and that doesn't work as much or as well as it has been, and the fire there, when I initiate the burning of sulfur, it doesn't self-sustain, which is a big problem, as well as like a fact that something has been changed, and I suspect that that's the cause. Because when I have had the calcium chloride there, you have to cover this up because it will suck up the water from there. When I have used that, there was basically, the fire was self-sustaining and it didn't like extinguish itself. So I suspect that that's the problem, so that will be changed, and when I change that I will also change the others. So for that I'm doing this, and this is just a test, so to see if this is working or not, but yeah, this is like information gathering. So the other problem that I'm experiencing is basically that the first thing, let's go through in order. So the bypass and the burn as like flow control system, that are those two, are working fine, and probably I have to do some debugging, but that's okay. The burner has to be fixed first, which means that I have to change and to do and dry and all that stuff, the desiccants, the absorbents, as well as like the other thing is I will have to do the testing, but to the test, basically that's like the I2C, I2C, the communication between the ESP32 based R32 bullshit and the Arduino will have like, can wait for now because it's not very important. The main thing is I will have to take apart again the catalyst chamber and replace the catalyst, the wool with the beads. The beads that has been calcined and coated with basically convert. So the beads have been soaked up into vanadium, and the vanadium salts has been like turned into vanadium pentoxide, and basically that's the catalyst to the same beads as that one that you have seen. But basically these beads, these little beads, but they have been also like soaked up in like the vanadium compound, as well as like they have been grinded, calcined into the, basically like heated up to like 400 degrees and kept at around for 1 hour to basically have the vanadium compounds break up, and it has been like slowly, gradually increased the temp over time. So yeah, I will have to take apart the main catalyst chambers and like replace the old sheet with the beads, and then we can start testing that shit out. Basically put the rock wool around it and then start the testing. So that will be interesting to see the data that I can collect. So I have this much vanadium solution pre-measured. I'm just gonna drip it on them.